Okay, today we're going to talk about application of right triangles trigonometry. Okay, Kev, can you read this for us?
It's suppose an operator at the top of a lighthouse site is a sailboat on a line that makes a 2-degree angle with the horizontal line. The angle between the horizontal and the line of sight is called the angle of depression.
Okay, there's a definition of angle of depression because you're going to have to know what this means on your homework tonight. So, by the way, look at how we define angle of depression. You have to look straight ahead, horizontal, right? And then look down to the object down there. Now, does it always have to make 2 degrees?
No.
No, if it's closer, it's going to be greater than 2 degrees.
But it can't be over 90. Right?
Yeah, it can't be over 90. Yeah, because it'll be like, well, I guess if it's right underneath you, it's 90. It can be like 91. Right. You know what I mean? Okay. What is then the somebody else now read next? How about? Okay. How about?
I got pictures. Really?
Tony. What's angle of elevation?
Angle of elevation.
Yeah. Can you read from here? At the same time.
At the same time, a person in the boat must look 2 degrees above the horizontal to see the tip of the lighthouse. This is an angle of elevation.
Good. It's an angle of elevation.
Also
Again.
from his horizontal.
Yeah. So in both cases, either for angle of depression or angle of elevation, you first look straight ahead horizontally, right? And then if you're up on the lighthouse, angle of depression will be how much you look down, and then if you're on the boat, you look straight ahead, and then how much you look up. That angle is the angle of elevation. Is that okay? So there's a picture, right? Okay. Oh, very good. And notice, Austin said it. What do you guys notice about these two angles? Austin, what did you say? Yeah, on these alternate interior angles. Not only that, these are 2 horizontal lines. So guess what? 2 horizontal lines are parallel. So if you have two parallel lines combine a transversal, and you have these alternate interior angles, these angles are what? Always congruent. So it turns out angle of depression from the tower and the angle of the elevation from the boat is always going to be the same. No, but yeah, I mean, it uses that theorem that if 2 parallel lines are cut by a transversal, then the alternate interior angles are congruent. Easy enough? Do you know what it? Okay, so important thing about the homework tonight is you have to answer what they're asking you to solve for, and not only that, you have to understand what they mean by angle of depression and angle of elevation and so forth. Sometimes people think that you see this angle that this 88 degrees, right, from the line of sight to the lighthouse. Some people think that 88 degrees is the angle of depression. Is that the angle of depression? No, you always look straight ahead, horizontally, then look down. That's the angle of depression. So don't make that mistake. Does that make sense? So what we mean by angle of depression, always, and also angle of elevation, you look straight ahead, horizontally, then either you look up or look down. If you look up, that's the angle of elevation. If you look down, that's the angle of depression. Okay? So let's do some examples here. Okay, hold on. So we have this problem. It says so it's the same picture. If the top of the lighthouse is 25 meters above the sea level, the distance x between the boat and the base of the lighthouse can be found in 2 ways. Okay, so what do they want you to find? The distance between x, the boat and the base of the lighthouse. Did it say the top of the lighthouse?
No.
So, like I said, when you do these problems, people give me, instead of this horizontal distance from the boat to the base of the lighthouse, guess what they give me? They give me the line of sight, the diagonal.
The transversal.
They could be asking you that, right? But in this case, are they asking you this diagonal? No. We're looking for this x. Yes, the horizontal distance. Does that make sense? So it says there are 2 ways to do this. I want you to all, as a group, figure out those 2 ways. Go ahead. Think about how you could find the x. I'll wait. But everybody's try. Here we go. So, Pomon, what did you guys come up with? Yeah, let's listen now. Okay, go ahead. Yeah.
From the angle of elevation or depression, 25 over x, and then the other way is from the
So give me one of the ways. So it's 25 over x is equal to what? tangent of 2 degrees is exactly right. Would you not agree?
Yeah.
Because you basically have a right triangle, right? This angle is 2 degrees, right? We know the height of this lighthouse, they told us, is 25. So 25 over x is going to be the tangent. Well, to find x, you multiply both sides by x and divide it by tangent of 2 degrees. So that's your exact answer, 25 over tangent of 2. And of course, you could punch that into your calculator or look up your table. And when you do, you get tangent of 2 degrees is about 0.0349, and then it becomes about 716.3 meters. Okay. What's the other way? How about Chris? What did your group come up with?
Tangent of 88.
Yeah, you could use tangent of 88 degrees, right? Is equal to what?
That's harder.
Actually, this is a bit easier. Tangent of 88 is what, Chris? X over 25. And so it's easier to find x, isn't that right? Because look, if this is 2 degrees, guys, listen, if this is 2 degrees and this is 90 degrees, this got to be 88, right? So if this is 88, you got to tilt your head a little bit this way. So opposite side of this 88 degrees is x. And we know the adjacent is 25. Therefore, you get x over 25 is tangent of 88. Multiply both sides by 25. You get x equals to 25 times tangent of 88. And since 88 degrees and 2 degrees are complementary of each other, we know that the tangent of 88 is reciprocal of this, right? Anyway, when you multiply this out, you get tangent of 88 is about 28.6363. When you multiply it, you get 715.9. Kind of interesting. Why do we not get the same exact answer here? Hold on. Why? How about? Shouldn't we get the same answer? Kristen, how can we get different answers? Are they different? Yeah, they're different tangent, but we should be getting the right answer. Same answer exactly, right? Yeah, these are approximates. Yeah, exactly right. Tangent of 2 degrees, tangent of 88, aren't these approximations? So if you were to use like higher approximation, the ones in your calculator, it'll be a lot closer. And that's the reason why. So don't, by the way, when you're doing your homework, do you have to do both ways? No, unless they ask you, right? All right, so yeah, you could use a calculator too. So it'll be more accurate because calculator would have better approximation than the one given in the table in the book, okay?
Wait.
Yes, question?
Can't you, for method 1, can't you just multiply by x, right? And then,
If you multiply by x, you get x times tangent of 2 degrees.
no, by x over, we cancel out the x.
Yeah, you multiply both sides by x. Then on the left, you get x times tangent of 2 degrees.
Yeah, then why didn't you here?
Then you have to divide by tangent of 2 to get x by itself. Austin? Okay. All right. Any questions?
If it's like tangent inverse, you divide it, right?
Well, tangent inverse, we'll talk about that a little later. We're not really dividing by it because tangent itself, right, is not a number or anything like that, right? So that's why we use the notation.
Wait, what?
When you're looking for the angle measure. Oh, are you talking about tangent of 2 degrees? What are you talking about? What's your question?
Just like tangent.
Okay, let me talk about it a little later because you're not really dividing by it. Tangent inverse is just looking at backwards, right? Okay. Tangent inverse is used to find the angle measure. If they give you, if you know the tangent of that angle, right? In order to figure out what the angle is, you have to use tangent inverse. We'll do that in a minute, okay? So just hold on to that, okay? Andrew, can you read this for us? This is sort of telling us why we get different answers here. It's sort of a summary. We just talked about it, but go ahead, read it for us.
Because the tangent values in the table are approximations, two methods give slightly different answers. In practice, the angle measurements will not be exact and the boat may be moving. In a case like this, we cannot claim high accuracy for an answer. A good answer would be the boat is roughly 700 meters from the land.
Yeah, so I'll actually have you write 716 or 715, that'll be fine, okay? Is this okay? All right, let's do another example now. Here we go. Example 2, you have something like this for your homework tonight. Like I said, you really have to understand what they mean exactly. Otherwise, if you have different idea than what they're saying, you're not going to get the right answer. It says, draw a diagram showing a person who is 1.5 meters tall standing 20 meters from the base of a building. Also show that the person sized the top of the building with an angle of 58 degrees. Then it says find the height of the building. So go ahead and write this down. See if you can understand what they're talking about. Write the question down and draw. Okay. And then see if you can figure out what they're asking. Okay, go ahead. Everybody try. I'll wait. Okay. So how many people was able to figure out that? Okay, first of all, you have this person right here. It's 1.5 meters high, right? Now, some of you say, what about the distance between where the person's eye is to the top of his head? Don't worry about that. Okay, we'll just take it as. Okay, yeah. So we'll just. Now, he's not, and this is important. The person is standing. He's not sitting on the ground or anything like that. Okay. So, question? Oh, okay. So, how many people got this picture? So the person is looking straight ahead, right? Remember, to get the angle of elevation, the person is first of all looking straight ahead, right, horizontally. So this is a picture you get.
Oh, I thought it was a tree at first.
Okay. Now, look at. Okay, so let me erase these. Okay, because people. Okay, so now, how far is this person from the building?
20.
Now, if he's 20 meters away from the building where his head is, how far is his head to the building? Straightly. Okay, it's 20 again. Okay, we don't, just like the distance from the top of the head to the eye, we don't care about those. So, it's both 20. So, look, you have this line of sight. You have the horizontal, right, line there, and you basically get a right triangle. Now, and is this height right here, this h, is that the height we're looking for? Is that the height of the building? No. This is h for, yeah, you gotta add h plus 1.5 because this is h right here. From here to here is 1.5, right? So therefore, you have to understand that the height you find is not the height of the building. You have to add the height of the person also because the person is looking straight ahead. Does that make sense? Okay, so go ahead and everybody finish, and I'll wait. Okay. Oh, some of you already done? Okay. Go ahead. So, let's figure out what this h is. So you basically have this right triangle, don't you? You have 58 degrees. You're looking for the height h, and you are 20 meters away. So which ratio should we use? Sine, cosine, or tangent? So we get tangent of 58 is equal to h over 20. And of course, to find the h by itself, you multiply both sides by 20. And you get, that's the exact answer. When you punch this into your calculator, you should get about 32.
Almost. It's like 32.
Yeah, you get about 32.
Oh yeah.
Okay, by the way, some of your calculators, you guys you have degrees and radian. You need to be in degrees, okay? Because we're looking at 58 degrees, right? Radian is another unit for angle measures. You don't want to be in radian. You have to be in degrees. Anyway, but if you look at the table, you have no problem. So if you look, so yeah, it's fine. And then, are we done with this? No, this is h represents the top of the building to where the person is looking at straight ahead, right? So you have to add 1.5 to that. So the answer should have been 33.5 meters approximately. Then the exact answer will be 20 times tangent of 58, whatever that is, plus 1.5. That's the exact answer. Yes?
Yeah. Sometimes you have to.
Yeah, so that's why, listen, no, that's why here's the approximated answer because these are both approximations. This is an exact answer because we said that the person said, the book says the person is 1.5 meters high, and this is the exact answer, 20 times tangent of 58.
The exact answer, too. It's 33.5005.
That's an approximate.
No, that's an approximate. As soon as you punch in tangent of 58, it's an approximation. Yes?
Should we put that exact answer on our homework, or is it okay if we have...
For this question, it's okay. Yeah, I want both of these, but for this one, approximate is fine, because I'll be asking for approximation. But I do need to see this work though. Well, how you got the 32 meters?
If we have the, if we have like the h equals 20 tangent...
Okay, I can't hear the question.
But...
Hold on, I can't hear the question, guys. Shh. Yeah.
If we just have like the exact answer for h in our notes and not the one where you add 1.5 to it,
That's fine. That's fine. Because the person's height, it's kind of an approximation because we're not, like someone said, the top of the head to the eye. You know, not really looking at that. So yeah, that's fine. All right. So let's then. Are there any other questions? Yes. Yeah, we'll tell you later. Okay. Any other question? Do you understand? Can you do something like this for your homework tonight?
Yes.
Okay. So please understand, right, that whenever you have this kind of question, people do not, they mess up. It's not because it's hard. They give me the wrong answer. They give me like the distance from the person, where the person is to the height, the top of the building. They're not asking for that in this case, are they? Okay, so please be careful. All right, good.